channel. So let's continue with the part 4, the chemistry of the elements. So in this part 4, we will discuss about the ionization energy. Okay, still under the identification of the periodic variation in physical properties. Okay, for ionization energy, or known as IE. So what is ionization energy? It is actually a minimum energy, okay, required to remove an electron from gaseous atom in its ground state. So usually most of the time this ionization energy will give you in positive kilojoule per mole. Okay, so it is actually depends on how tightly the electron is held in the atom. Okay, so when you have the larger amount of ionization energy, so the more difficult to remove the electron. Okay, so here when we talk about ionization energy, usually you need to imagine something positive. Okay, alright, so it is actually formation of cation. Okay, alright, so first example here. Okay, let's say I have the first ionization energy. Okay, this is, for example, I. Okay, in gaseous atom. Okay, so this energy, oh sorry, this is actually energy, this is the atom X, not I, X. Okay, so this X, okay, this atom receive first ionization energy, and it will become X plus, and it removes one electron. And then here, alright, so I think it should be X plus here. Oh, right, let me do the correction here. It should be X plus. Okay, let's say this X plus receive second ionization energy, it will become X2 plus and remove another one electron. Okay, then this should be X2 plus. Okay, alright, receive another third ionization energy, it will become X3 plus and remove another one electron. So from here, okay, most of the time the third ionization energy will have the highest energy, okay, compared to the second one and the first one. Okay, right, so in this one is positive kilojoule per mole. Usually positive will give you endothermic reaction. Okay, endothermic reaction. Alright, so what are the trends of the ionization energy for periodic table? And down the group, okay, from top to the bottom, first ionization energy decreases. Alright, why? Because of the size. Okay, so electrons are further away from the nucleus and it will have more shielding, and so what happened here, easier to remove the outermost electron. Okay, then second one, across a period, so the first ionization energy increases because we have smaller size of the atoms. Okay, and then so what happened here, atomic radius decreases, so the outer electrons are closer to the nucleus, so more strongly attraction to the center, but we still have similar shielding effect, and it is actually difficult to remove the outermost electron. That's why the first ionization energy increases across a period. So this is example of the first ionization energy trends. Okay, here, alright, based on the atomic number. And then we have two exceptions, okay, to first ionization energy trends. For example, here for the first one we have beryllium and boron. Okay, so in this case you need to write down the electron configuration. Beryllium, okay, we have 4, 1s2, 2s2, while for the boron 5, okay, 1s2, 2s2, 2p1. Okay, it is actually easier to remove one electron from the boron, okay, at p orbital, because it is only has one electron in the p group compared to beryllium. Okay, in order to remove electron here, you need to remove from the core electron from the 2s. So the first ionization energy for the boron here is much more smaller compared to the beryllium. Okay, and then okay, then second one for the nitrogen and oxygen. Nitrogen, okay, nitrogen 7, this is 1s2, 2s2, 2p3, and then oxygen we have 8, okay, 1s2, 2s2, 2p4. Okay, right, in this case it is easier to remove one electron from the oxygen here compared to the nitrogen. Why? Okay, so here this is half filled, this is partially filled, right? So half filled is more stable than the partially filled, so more energy is required, okay, in order to remove electron in the nitrogen, okay, compared to the oxygen. Okay, and then other than that, here the explanation here, the electron repulsion makes it easier to remove the outermost paired electron, okay, other than half filled and also partially filled electron configuration. Okay, then what about the second and higher ionization energies? Okay, so here it is actually energy required to remove a second outermost electron from a ground state atom. Okay, so subsequent ionization energies increase greatly once an ion has reached the state like that of a noble gas. But for elements that reach a filled or half-filled orbital, by removing 2 electrons, so the second ionization energy is lower than expected. Okay, so these are example for the ionization energy. Alright, so as you can see here, okay, from this table itself, okay, second ionization energy is higher and compared to the first one, but the third one will have the highest energy, because this usually in the third ionization energy, it involves with the core electron. Okay, so core electrons will have higher attraction with the nucleus, so it is actually difficult to remove them. Okay, so that's why the third ionization energy will become higher. So, what are the factors that determine the ionization energy? We have here, first one is the nuclear charge. The higher the nuclear charge, it will give you the greater ionization energy because of the size, okay. And then the distance, okay, this is actually also the size, okay. The distance from the nucleus, also it will decrease the ionization energy. And then filled and half-filled orbitals have lower energy, so achieving them is easier, so it will give you lower ionization energy. Okay, and last one is the shielding effect. Shielding effect, it is actually related to the size and number of orbital. Alright, so that's all for this part 4. So I'll see you guys in part 5, the last part for this topic. Bye!